Hello, everyone, and welcome to the Speak Smart podcast. Today, we're diving deep into a topic that's both familiar and awe-inspiring.
Oh, yeah.
Our very own solar system. You've provided a treasure trove of sources, articles, transcripts, even some snippets from other science podcasts. And I can't wait to explore them with you and our expert to uncover the most mind-blowing nuggets about our cosmic neighborhood.
I'm excited too. What's fascinating about the solar system is that even though it's something we learn about from a young age, there's always something new to discover, a fresh perspective to gain. I'm particularly intrigued by the mix of sources you've gathered. It's like having different lenses to view this well-known yet ever-surprising subject.
Okay, let's launch into it.
Yeah.
You know, sometimes I forget just how mind-bogglingly huge our solar system is. I mean, at the heart of it all is the sun. This gigantic star that accounts for, get this, over 99% of the solar system's total mass.
Wow.
It's like the ultimate cosmic heavyweight holding everything else in its gravitational grip.
It's a powerful image, isn't it? And it highlights a crucial concept. The sun's gravity is the invisible force that orchestrates this grand cosmic ballet. It's what keeps the planets in their orbits shaping their paths and influencing their destinies.
It's like the sun is the conductor of this grand orchestra, and each planet is playing its own unique tune.
I like that.
Speaking of planets, our sources explain that there are 8 planets in our solar system, neatly categorized into 2 main groups: the inner terrestrial planets and the outer gas and ice giants.
This division isn't just about aesthetics, it's about composition and distance from the sun. The inner planets Mercury, Venus, Earth, and Mars are closer to the sun. Composed primarily of rock and metal, think of them as the sturdy, compact members of the solar system family.
And then we have the outer planets, Jupiter, Saturn, Uranus, and Neptune. These massive swirling behemoths composed mostly of gases like hydrogen and helium. They're the giants of the solar system, with atmospheres so thick and turbulent that they make Earth's weather look like a gentle breeze.
It's interesting to consider how this division arose from the early solar system's formation. The inner planets, being closer to the sun, experienced higher temperatures, which drove off lighter elements, leaving behind the denser, rocky materials.
So it's like the sun's heat acted as a cosmic sculptor, shaping the composition of the planets. It makes you appreciate how the solar system's history is etched into the very nature of its inhabitants. Now, how about we take a quick tour of each planet, highlighting some of the most fascinating features, starting with Mercury, the smallest planet and the speedster of the solar system, whipping around the sun in just 88 Earth days.
Mercury is a fascinating world of extremes. Because it's so close to the sun, it experiences scorching temperatures during the day, hot enough to melt lead.
Really?
But on the flip side, its nights are incredibly frigid, with temperatures plummeting to hundreds of degrees below freezing. Imagine that kind of temperature swing.
Talk about a harsh environment. It's amazing that anything could survive in those conditions. And our sources mention that Mercury's surface is heavily cratered, making it look like our moon's long-lost twin. It's a testament to the intense bombardment the planet has endured over billions of years.
It's a reminder that the early solar system was a chaotic and violent place, with objects constantly colliding and reshaping each other. Mercury, being so small and close to the sun, bears the scars of that turbulent past.
Next on our planetary tour is Venus, often called Earth's sister planet because of its similar size and mass. But as we delve deeper, we find that this sister has a rather fiery personality.
Venus is a dramatic example of what can happen when a planet experiences a runaway greenhouse effect. Its thick atmosphere, composed primarily of carbon dioxide, traps heat from the sun, creating a scorching surface that's even hotter than Mercury's, despite being farther away.
It's almost like Venus took the concept of global warming to the extreme. It makes you wonder if Venus could have once been a more hospitable place, perhaps even with oceans like Earth's, before this runaway greenhouse effect took hold.
It's a compelling thought, and it highlights the delicate balance that can exist between a planet's atmosphere and its habitability. Studying Venus helps us understand how atmospheric processes can shape a planet's destiny.
Now let's shift our focus to our home sweet home, Earth, the third rock from the sun, and the only planet we know of that harbors life. What I find truly remarkable is how perfectly Earth is situated within the solar system's habitable zone, that sweet spot where conditions are just right for liquid water to exist.
It's a cosmic Goldilocks zone. Not too hot, not too cold, but just right for life as we know it to flourish. Earth's unique combination of a protective atmosphere, liquid water, and a stable climate has allowed life to evolve and diversify over billions of years.
It makes you realize how precious and rare our planet truly is. Speaking of precious, how about we move on to Mars? the fourth planet from the sun, and often dubbed the red planet because of its rusty, iron-rich soil.
Mars has captivated human imagination for centuries, and for good reason. It's the planet that's most similar to Earth in many ways. It has polar ice caps, evidence of past liquid water seasons, and even a day that's only about 40 minutes longer than an Earth day. You wouldn't have to adjust your sleep schedule too much if you ever moved there.
That's right. And Mars boasts some incredible geological features, like Olympus Mons, the largest volcano in the solar system. It dwarfs Mount Everest, rising to a towering height of over 13 miles. And then there's Valles Marineris, a canyon system so vast that it makes the Grand Canyon look like a ditch.
These features are testaments to Mars's dynamic geological history, hinting at a past when volcanoes erupted and rivers flowed across its surface. It's this tantalizing evidence of a wetter and warmer past that fuels our fascination with Mars and the search for signs of ancient life. And speaking of that search, Mars is currently buzzing with robotic explorers. We've got rovers like Curiosity and Perseverance roaming the Martian landscape, acting as our eyes, ears, and even hands on the red planet. They're taking stunning pictures, analyzing rocks, drilling into the soil. It's like having a team of robotic geologists working tirelessly to unlock Mars's secrets.
It's mind-blowing to think that we have these sophisticated machines operating millions of miles away, sending back a constant stream of data that's revolutionizing our understanding of Mars. And Perseverance is even collecting rock and soil samples that will eventually be brought back to Earth, the first ever Martian samples to be studied in our labs.
That sample return mission is going to be a game changer. It will allow scientists to analyze those Martian rocks and soil with instruments and techniques that are simply too large and complex to send to Mars. We might finally get definitive answers to those burning questions about past life on the red planet.
It's like a Martian care package delivered right to our doorstep. But let's not forget about the other residents of our solar system. Now it's time to journey to the outer solar system, where we encounter the gas giants. Started with Jupiter, the undisputed king of planets.
Jupiter is truly a behemoth, so massive that you could fit all the other planets inside it with room to spare.
Wow.
It's a swirling ball of gas, mostly hydrogen and helium, with colorful cloud bands and colossal storms that rage for centuries.
One of those storms. The Great Red Spot is so iconic that it's been observed for over 400 years. You know, it's fascinating to think that a storm could last for centuries. It makes Earth's hurricanes seem like fleeting gusts of wind in comparison.
The scale of these storms is mind-boggling. The Great Red Spot is so large that you could fit 3 Earths inside it. And Jupiter isn't just about size and storms. It also has a fascinating entourage of moons.
Right. Our sources mention the Galilean moons, Io, Europa, Ganymede, and Callisto, each with its own unique personality and quirks. Io, for instance, is the most volcanically active body in our solar system, spewing out plumes of sulfur and lava. It's like a cosmic fireworks show.
Io is a dramatic example of tidal heating. Jupiter's immense gravity creates tidal forces that stretch and squeeze Io's interior, generating the heat that fuels its volcanic activity. It's a reminder that gravity isn't just a force of attraction, it can also be a source of intense energy.
And then there's Europa, an icy moon that's thought to harbor a vast, salty ocean beneath its surface. Scientists believe that Europa's ocean might contain more water than all the oceans on Earth combined, and that it could potentially support life.
Europa is one of the most intriguing places in our solar system, and it's a prime target in the search for extraterrestrial life. Imagine an alien ocean teeming with creatures unlike anything we've ever seen before, hidden beneath a shell of ice. It's a thought that sends shivers down my spine.
I'm getting goosebumps just thinking about it. It's amazing how much diversity and potential for life exists within our own solar system. And speaking of diversity, next up on our gas giant tour is Saturn, the ringed wonder of our cosmic neighborhood.
Saturn's rings are truly a sight to behold, a celestial ballet of ice and rock particles orbiting the planet. They're so vast and reflective that you can see them with a simple telescope from Earth. It's no wonder that Saturn has been called the jewel of the solar system.
You know, I've always wondered what it would be like to fly through Saturn's rings. Would it be like navigating a cosmic minefield? Or would it be more like floating through a shimmering ethereal cloud?
It's a captivating thought. While we haven't sent a probe directly through the rings, data from the Cassini spacecraft, which orbited Saturn for over a decade, suggests that the rings are surprisingly sparse. The particles are spread out over vast distances, so it's likely that a spacecraft could navigate through them without too much risk of collision.
So it's more like a cosmic mist than a solid wall of ice and rock. That's a relief. And Saturn isn't just about the rings, it also has a fascinating collection of moons. One of them, a Titan, is so large that it's even bigger than the planet Mercury.
Titan is unique among moons in our solar system because it has a dense atmosphere primarily composed of nitrogen, similar to Earth's atmosphere. And on its surface, we've discovered lakes and rivers of liquid methane and ethane.
Wait, so there are actual bodies of liquid on Titan?
Right.
But they're not water. That's wild. It's like a glimpse into an alternate reality where the rules of chemistry are different.
Exactly. And some scientists speculate that Titan's unique environment might even harbor exotic forms of life that rely on methane instead of water as their primary solvent. It's a tantalizing possibility that pushes the boundaries of our understanding of what life could look like beyond Earth.
That's incredible. It's amazing how much diversity and potential for life exists within our own solar system. And now it's time to venture even farther out to the realm of the ice giants, Uranus and Neptune. They often get overlooked, but they're just as fascinating as their larger siblings.
Absolutely. Uranus and Neptune are called ice giants because, unlike the gas giants, they have a higher proportion of heavier elements such as water, ammonia, and methane, mixed in with their hydrogen and helium atmospheres. These elements exist in a fluid state under the immense pressure and temperature conditions found deep within these planets.
One thing that's always struck me as odd about Uranus is its extreme tilt. It's like it's rolling around the sun on its side. What could have caused such a dramatic tilt?
That's a great question, and one that has puzzled scientists for years. The most likely explanation is a giant impact early in Uranus's history, a cosmic collision that knocked it off its axis. Imagine the forces involved in an event like that.
It must have been a cataclysmic event.
Yeah.
And this tilt has some pretty strange consequences, right? Like seasons that last for decades.
Exactly. Because of Uranus's tilt, its poles experience extreme variations in sunlight throughout its orbit. Each pole gets about 42 years of continuous sunlight, followed by 42 years of darkness. It's hard to even imagine what that kind of seasonal variation would be like.
Talk about extreme weather. And what about Uranus's atmosphere? Is it as stormy as Jupiter's or Saturn's?
Surprisingly, no. Uranus's atmosphere is actually quite bland compared to the other gas giants. It has some faint cloud bands and storms, but they're not as dramatic or long-lasting as the ones we see on Jupiter or Saturn. And the methane in its atmosphere gives Uranus its pale blue-green hue.
It's interesting how each planet has its own unique character. And does Uranus have rings like Saturn?
It does, but they're much fainter and less prominent. They were actually discovered by accident in 1977 when Uranus passed in front of a star. And scientists noticed that the star's light blinked on and off as the rings passed by.
It's amazing how these discoveries are often made through serendipity and keen observation. And what about moons? Does Uranus have any interesting moons worth mentioning?
Uranus has 27 known moons, all named after characters from the works of William Shakespeare and Alexander Pope. Some of the most notable moons include Titania, Oberon, Umbriel, Ariel, and Miranda. Miranda in particular is quite intriguing because of its chaotic surface, which suggests a violent past. It's like someone took a bunch of different landscapes and mashed them together.
It's amazing to think about these distant worlds, each with its own unique story to tell. Now let's move on to Neptune, the eighth and farthest planet from the sun. What makes Neptune stand out from the crowd?
Neptune is similar to Uranus in size and composition, but has a much more active and dynamic atmosphere. It's known for its intense winds, which can reach speeds of up to 1,200 miles per hour, the fastest in the solar system. And it also has a striking deep blue color, which comes from the methane in its atmosphere, just like Uranus. But Neptune's color is much more vivid.
1,200 miles per hour, that's mind-blowing. It makes Earth's hurricanes seem like gentle breezes. And what about storms? Does Neptune have any notable storms like Jupiter's Great Red Spot?
Yes, Neptune is known for its Great Dark Spot, which was a massive storm similar in size to Jupiter's Great Red Spot. It was first observed by the Voyager 2 spacecraft in 1989, but it has since disappeared. However, other similar storms have been observed on Neptune over the years, showcasing its turbulent atmosphere.
It's fascinating how these storms can rage for years, even decades, on these gas and ice giants. And does Neptune have rings and moons as well?
Yes. Neptune has a faint ring system composed of dust and small particles, and it has 14 known moons, the largest of which is Triton. What's really fascinating about Triton is that it orbits Neptune in the opposite direction of the planet's rotation. This retrograde orbit suggests that Triton might have been captured by Neptune's gravity rather than forming alongside it.
A captured moon. That's like a cosmic kidnapping. It makes you wonder where it came from and how it ended up in Neptune's gravitational clutches. And what else is interesting about Triton?
Triton is one of the coldest objects in our solar system. With surface temperatures around negative 391 degrees Fahrenheit, it has a very thin atmosphere composed mostly of nitrogen. And it even has geysers that erupt nitrogen gas and dust.
Wow. So even in this frigid, distant world, there's geological activity. That's incredible. It makes you wonder what other surprises might be lurking out there in the depths of our solar system.
Absolutely. And speaking of surprises, let's move beyond the planets and delve into the realm of asteroids, comets, and dwarf planets. These objects might not be as grand as the planets, but they hold valuable clues to the solar system's formation and evolution.
Right. They're like the cosmic leftovers, the bits and pieces that didn't quite make it into planets, but still have fascinating stories to tell. So let's start with asteroids. What exactly are asteroids, and where do they hang out in our solar system?
Asteroids are rocky, airless remnants left over from the early formation of our solar system. About 4.6 billion years ago, think of them as the rubble from the solar system's construction project. Most of the asteroids reside in a vast region between Mars and Jupiter called the asteroid belt, almost like a cosmic junkyard of leftover planetary material.
So it's like a cosmic demolition derby out there in the asteroid belt. And what about comets? How are they different from asteroids?
Comets are also leftovers from the solar system's formation. But unlike asteroids, they're icy bodies. They're like dirty snowballs, composed of ice dust and rock. They originate from the outer regions of our solar system, in areas called the Kuiper Belt and the Oort cloud.
And what's with those spectacular tails that comets are known for? How do they form?
Those tails are what make comets so visually stunning. When a comet gets close to the sun, the heat causes the ice and other volatile materials in the comet's nucleus to vaporize, creating a glowing halo around the nucleus called the coma. As the comet continues to move, the solar wind and radiation pressure from the sun push this material outward, forming the iconic tails.
So it's like the sun is giving the comet a cosmic blow-dry, and those tails can stretch for millions of kilometers, right?
Yes, comet tails can be incredibly long, sometimes stretching for hundreds of millions of kilometers. It's a spectacular display of the interplay between the sun's energy and the volatile nature of comets.
Now let's talk about dwarf planets. I know Pluto's the most famous one, but what exactly makes a dwarf planet different from a regular planet?
Dwarf planets are essentially celestial bodies that are big enough to be round due to their own gravity, but they haven't cleared their neighborhood around their orbit. In other words, they share their orbital space with other objects of comparable size. That's the main distinction between planets and dwarf planets.
So Pluto got demoted because it hasn't cleared its neighborhood. That seems a bit harsh.
I know it was a controversial decision at the time, but it's all about clarifying the classification of objects in our solar system. Besides Pluto, other notable dwarf planets include Ceres, located in the asteroid belt, and Eris Haumea and Makemake, which reside in the Kuiper belt.
It's amazing how much diversity there is in our solar system, from giant gas planets to tiny icy worlds. It makes you wonder what other mysteries are out there waiting to be uncovered.
Absolutely, and that's what makes exploring our solar system so fascinating. Each new discovery brings us closer to understanding our place in the cosmos and the processes that shaped our world and countless others.
Well, we've journeyed from the scorching heart of our solar system to the icy outer reaches, encountering a breathtaking array of planets, moons, and other celestial wonders. But as you know from the sources you provided, there's one destination that holds a special place in our collective imagination. Mars, the red planet.
It's fascinating how Mars has captured our attention for centuries, inspiring countless science fiction stories and fueling dreams of human exploration and even colonization. But what's truly exciting is that Mars isn't just a fictional playground. It's a real-world target for scientific investigation and potential future human settlements.
You know, it always gets me. The fact that Mars is relatively close to Earth, at least compared to those outer gas giants.
Right.
Our sources mention that it's our closest planetary neighbor after Venus. And a day on Mars is only about 40 minutes longer than an Earth day. So you wouldn't have to adjust your sleep schedule too much if you were moved there.
Those are practical considerations for sure, but there are also deeper reasons why Mars holds such allure. It shares some intriguing similarities with Earth, like those polar ice caps that shrink and grow with the seasons just like ours.
And let's not forget that tantalizing evidence of past liquid water. We're talking dry riverbeds, ancient lake basins, features that hint at a wetter and warmer period in Mars's history, perhaps even an environment that could have supported life.
That's the billion-dollar question, isn't it? If Mars had liquid water in the past, could it have harbored life? And if so, are there any traces of that past life still hidden beneath the surface? waiting to be discovered. That's what drives a lot of the current Mars exploration efforts.
And speaking of exploration, we have some incredible robotic emissaries currently working hard on Mars. The Curiosity and Perseverance rovers are like our off-world field researchers, equipped with cameras, drills, and instruments that analyze everything, from the composition of Martian rocks to the presence of organic molecules.
It's mind-boggling to think that we have these mobile laboratories roving around on another planet, sending back a constant stream of data that's revolutionizing our understanding of Mars. Perseverance is even collecting rock and soil samples that will eventually be brought back to Earth for analysis. The first ever Martian samples to be studied in our labs.
Imagine the secrets those samples might hold. But robotic exploration is just one step right. There's this grand vision of sending humans to Mars someday, actually setting foot on that rusty red soil and exploring its canyons and volcanoes firsthand.
The idea of human missions to Mars is no longer just a science fiction fantasy. It's becoming a tangible goal, albeit one with enormous challenges. We'd need to develop spacecraft capable of protecting astronauts from the hazards of deep space travel.
All right.
Radiation, micrometeoroids, the psychological toll of isolation.
And once we get them there, how do we keep them alive? We need to figure out how to provide them with the essentials. Breathable air, clean water, food, and shelter from the harsh Martian environment. We're talking about building habitats, developing sustainable food production systems, essentially creating a mini Earth on Mars.
It's a monumental challenge, but also an incredible opportunity for innovation. There are fascinating ideas being explored, like using resources already present on Mars to help sustain human life. For example, extracting water ice from the polar caps or subsurface aquifers, or using Martian soil to grow crops.
It's like learning to live off the land, but on another planet. Then there's this concept of terraforming Mars, transforming it into a more Earth-like world. It sounds like something straight out of a science fiction novel. Is that even remotely possible?
Terraforming Mars is a long-term, highly ambitious goal, and it's still largely in the realm of theoretical possibilities. It would involve complex processes like releasing greenhouse gases to warm the planet, thickening the atmosphere, and creating bodies of liquid water. It would be a monumental undertaking, spanning centuries or even millennia. But some scientists believe it's theoretically achievable.
It boggles the mind to think about the possibilities, both in terms of what we're learning about Mars right now and what the future of human exploration might hold. It feels like we're on the cusp of a new era with Mars as our next giant leap.
It's an incredibly exciting time. And it's not just about the scientific and technological advancements. It's about pushing the boundaries of what's possible, expanding our horizons, and inspiring future generations to continue exploring the vast unknown.
Well, on that note of cosmic wonder, I think we've reached the end of our solar system deep dive. We've journeyed from the fiery heart of our sun to the icy realms of the outer planets, encountering a dazzling diversity of worlds along the way. But as we've seen, the journey of exploration is far from over.
There's still so much more to discover, especially when it comes to our enigmatic neighbor Mars. And who knows what other secrets our solar system holds, waiting to be revealed by future generations of explorers.
So keep looking up, keep asking questions, and keep that sense of wonder alive. Thank you for listening to the Speak Smart podcast. Don't forget to subscribe to my channel, like, and hit that notification bell so you don't miss any future episodes. We'll see you next time.